So hello everyone, welcome back to the channel. Today we are going to solve the problem minimum BST sum subtree. So given a binary tree and a target, find the length of the minimum subtree with the given sum equal to target, which is also a binary search tree. So let's understand. So basically we are given a binary search tree, okay, and a binary tree, not binary search tree, okay, and we are given a target. So what we want to find a minimum length subtree with sum equal to target, and that should be the BST. Okay, so let's better understand with an example. So let's say I take this subtree. Subtree means like the bottom part, some covered bottom part of the tree. Let's say I have tree something like this. Okay, so subtree will be like this is a subtree, this is a subtree, this can also be the subtree, but subtree is something like that covers full bottom part. Like this is a subtree, this is a subtree, this is also a subtree. So this is the thing, and we have to find the minimum length subtree with sum equal to target. So if I add this 17, 16, 33, so the sum is equal to 38. So we will say this subtree, the bottom part, the full covered bottom part is giving 38 as sum. Okay. So it is giving 38 as sum. Second thing, we have to check whether it is BST. So let's check whether it is BST. What is the property of BST? Property of the BST is, let's say I have a node. So the all the nodes which are less than which are left to the node should be smaller, and all the nodes which are to the right of this node should be greater. That is the thing. So left should be smaller and right should be greater. That is, all nodes should be greater and all nodes should be smaller at the left. Okay. So this is the property of the BST. So if I check here, like let's say here is 17, here is n. So uh, here when I check, I have to check only this subtree for BST. So I will say, okay, this is 5. All nodes are greater to the right. Yes. Okay. For 5, it's done. So let's check for 17. All nodes are greater. No nodes are available. Okay. All nodes are smaller. Yes. Right. Okay. Let's come to 16. Let's come to 16. 16 has no nodes, so obviously its leaf node is fine. So this is a valid BST. So length is what? 1, 2, 3. 3 nodes. So length is 3 nodes. Similarly, you will find another BSTs. So answer will be 3 nodes only because we have only one BST. We have to find the minimum length of that subtree. Okay. So this is a question. Similarly, let's check this test case. So when I check, I will say like this one will give me target is equal to 73. But why it will not work? Because for 17, it's right. For 10, all nodes are greater. Yes, 17 is greater. All nodes are here greater. For 10, for 23, all nodes are smaller. Yes. All nodes are greater. No, 23 is equal. We want greater. All nodes should be greater than 23. So I will say this is not a valid BST. That's why we will return -1 as answer here. Okay. So this is the question. So how to approach this question? So before approaching the question, let's understand some of the observation that we want. Like first thing that we want, like we are given binary tree. Okay. So we want to find a subtree with BST. So whenever these subtree type questions come now, the traversal should start from the bottom. Why should start from the bottom? Because let's say I have this tree, okay, and let me cover this tree. So for subtree questions, like whenever we go down, then we go up. Why? Why? Because actually I don't want these sum initially. Let's say I am here. I will take this sum. I will take this sum. I will take this sum. This is the one subtree. Now when I go above, I will take this sum. I will take this sum. This is another subtree. So I will going from bottom to top while taking every subtree one by one. Similarly, take. Then this will become another take. So something like this. So subtree question goes like this. So this is the one thing that I want to tell you. Secondly, for checking the subtree BSC, that subtree is BSC or not. Obviously, what I want. Let's say I am here. What I want that all the elements to the left of this should be smaller, as I already said. Similarly, all the elements to the right of the it should be greater. Okay. So this is the thing for checking the BST. That whenever I come from the bottom to top, what things I require? First thing I require sum. Why? Because obviously when I go above, let's say I take this node, then 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 I take this node. So this is one subtree. Similarly, this is another subtree. So whenever take this subtree, take this subtree. When this node comes, this will combine this subtree and make another subtree. So something like this. So we want to take from the bottom what sum. Second thing, we want maximum and minimum from the bottom. Why? Because as I already told, let's say, like for BST, if I rub all of these things and tell you about this again, like here is, let's say I say, this is left maximum, this is left minimum, this is right maximum, this is right minimum. That means all the greater elements, all the greater and smaller elements here, and all the greater and maximum and minimum elements. That means, okay. So when I am here, what I want, this should be greater than what? Left maximum. Why? Because I want all the elements which are greater here. It should be greater because let's say I am at 73 here. And what I want, I am, let's say, at 87. Obviously, it's not greater because 87 is greater. So what I want, tell me the greatest to greatest element here, and 73 should be greater than that. Similarly, tell me the smallest to smallest elements here. Let's say I have 101 smallest to smallest. So 73 smaller work. But let's say smallest to smallest 65. So obviously it will not work, as I already told in BST, that these elements should be greater than this node. Okay. So like this BST works. So what we want from the bottom, maximum and minimum. Okay. Every time, like tell me the, like when I check this node, what I will say, that whether this roots data should be greater than what? Left maximum. Also root data is less than right minimum. Okay. So these are the two things that we require, that it should be uh, greater than left maximum and right minimum. Similarly, when I go above, then I will take the maximum of this, these three nodes, like root data, left maximum and right maximum. Similarly, minimum will be root data, left minimum, right minimum, to get the maximum and minimum till this node. So when I go above, I will check whether this root data again greater than maximum and whether this root data is again greater than minimum. So this is something like that we have to approach. And I think that I have to tell, like if you already know, like in the BST what happens. Like in BST, when there is a root node, I will check, okay, this is greater than this. But only this is not complete. Like I can tell that this is the BST by telling only this node is greater than this and this. Let's say I take this example. So let's say I say 23 is greater than 10, 23 is less than 23, no. Okay. Similarly, if I take this, let's say I take 5 here. Let's say I take 11 here. Okay. So 23 is greater than 11, maximum of all. 23 is smaller than this. Let's say it is 24. Okay. So 23 is smaller than 24. Yes. But if I take this 10, is 10 is greater than 11? No. So at every time when I start from the bottom, I have to check whether the below tree is BST. If the below tree is BST, let's say I make a variable is BST, then I will check if below tree is BST, then only I will able to check whether the sum matches the target. Then I will take the minimum length of the tree. So that is somewhat like from the bottom, we have to check one more thing, that is it BST. Also, at every point, we have to check root data is greater than left maximum, root data is less than right minimum. And third thing that we have to check, we have to get the sum from the bottom. While coming up, I will take the sum one by one. And fourth thing that we want the length, because every time when the sum matches the target, I want to take the minimum length. So from the bottom, when I come above, I will take the length. Okay. So let's collect all this information to dry run this approach. Okay. So let me take this example, and let's say minimum length is initially 1E9, and this is a tree that is given, binary tree, and the target is 38. And we want to find whether there is a BST with whose target, whose sum, subtree sum is equal to 38, and we have to find the minimum length for that. Okay. So let's say I come above. So when I have null, obviously the length of the tree is 0. So what I will be doing, as I already said, so I will be going to use 5 parameters: length, maximum, minimum, and what is the length till this subtree? 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 What maximum? What is the maximum till this subtree? What is the maximum till this subtree? What is the maximum? What is the minimum? Like this. And similarly, what do we want, like sum? What is the sum till this subtree? What is the sum till this subtree? What is the sum till this subtree? Fifth thing that we require, flag. What flag we tell? Is the bottom tree is BST? If it is BST, then I need to take this root into consideration when it matches the sum. Otherwise, if below is not BST, so how can I validate that this subtree is BST? For checking the BST, we have to check the whole tree should be BST. Okay. So this is the thing. Okay. So now these 5 parameters I will be going to use while dry run them. So now let's go for the root. I will go to left. I will go to left. Now for this null, obviously what I will have, I have 5 parameters. Length is 0. Obviously length is 0. There is no node here. Maximum, obviously by default we take -29 and minimum will take 189. Sum will be 0 till this subtree obviously. And flag is true. Why? Because this below, obviously it's a BST. Null is obviously BST. Okay. Now 5 will call for right. Now it will call for left. It will call for left. Now similarly for this null, same thing we will do. 189, 0, true, etc. Now similarly we will go to right. 0 minus 29, 189, 0, true. This is somewhat like that. Okay. So now for 16, I will check. First thing. First thing I will check is below tree BST is below two subtrees left and right are BST. So I will say yes, this is true. Okay, this is true. Okay. So is current tree BST? So I will say okay. So maximum is -29. So 16 is greater than -29. Secondly, 16 is less than minimum of the right, as I said. So 189, obviously it is less than 189. So I will say okay. This is also BST. So first thing that we have, what is the length till this BST? 0, 0, 0, 0, and one node is added, +1. So I will say left tree length plus right tree length +1. So I will say 1. And what is the maximum till this subtree? Maximum 16 -29 -29. What is the maximum of all? 16. So I will say okay, maximum is 16. Now, what is the minimum till this? Obviously, 189, 189, 16. Obviously, but till the minimum 16. What is the sum till this? 0, 0 plus 16. Obviously, 16. So sum will be 16. So is this valid BST as I already told? Yes. So this will be true because it is greater than maximum and it is less than minimum. Okay. Now I come to 16. Now we will say, okay, what is the sum till this? Sum till this is 16. Obviously, fourth parameter is sum. So I will say 16 matching the 38. No. So just go ahead. Go ahead. So now when I came here, now I will come back. Now similarly, this 17 will call this call and this 17 will say 0 minus 29. 29, 0, true. And okay, fine. That's not. Okay. Now for 17. Now for 17, we will say what is the length? Left subtree length is 1. Okay. Right subtree length is 0. Adding me +1. So what will be the total length? 2, comma. What is the maximum? Maximum till this is 16. Maximum till this is -29. Maximum of both and this. In total, it will make 70. Okay. What is the minimum of this? Minimum this is 16, 29, and 17. Obviously, minimum of left, minimum of right, and the current 16. And what is the sum till this? Left subtree sum, right subtree sum, adding this. So sum will be obviously 33. And what is this a valid BST? So for that, I will say, okay, 17 is greater than maximum. What is the maximum till this? 16. What is the minimum till this? 29. Yes. Okay, so then I will say it is a true that till this point I am sure that this is a BST. Okay. So let's try to raise this. Now then this call will go above and come to 5. Now for 5 we will say, okay. Now for 5 we will say, what is the length? 0 plus 2 plus this element 3. Maximum -29, maximum till this, and maximum of this. 3 maximum will be 17 obviously. Minimum will be 5. And what is the sum? 38. And is this a valid BST? So I will say 5. The maximum till is -29. And minimum of this, we have to check for maximum here. We have to check for minimum here. So minimum till this is what? Minimum till this is 16. So I will say, okay, this is 16, so this is fine. So I will say this is true. So is sum matching? Yes, it is matching. So what is the length? 3. So minimum length instead of 189, it will become 3. So similarly, we go ahead. Obviously, there will no BST found. So minimum length 3. So if somehow any subtree found with minimum length, we will update this minimum length. We know this is normal if minimum length is greater than current length. Okay, so this is normal. So what is the main question? Question is really easy. Just the question wants the knowledge of some BST that and knowledge of how to handle the subtrees. Rest all is things normal from going to bottom to top. Length, maximum, minimum, sum, flag, these all things are required. Okay. So now in the implementation part, one thing that we can do, like for every, let's say this is a subtree, this is a tree, binary tree. So for every subtree, I will return maximum, minimum, vector, and this, but this will become somewhat hectic and more space consuming. So instead of that, what we will do, let's say I have length 0, 0 initially. I will say length 1, 1, 1 plus 1, 2, 3, 1 plus 1, 2, 2 plus 1, 3. So just I will return, make a int function, which will return the length of the subtree. If you normally know the normal way to calculate the length of the subtree, total length of the tree, okay, left length plus right length plus 1. This is a somewhat left length plus right length plus 1. This you know, okay. Now, how can we handle that these extra four parameters, maximum, minimum, sum, flag? So for that, I will pass a function which have these four parameters and they will be passed by reference. So let me tell you while coding this approach. So let's code up. Okay, let's code a bit. First, let's write the normal function that how to find a length of the binary tree. Just write that function. So how to find the length of the binary tree? So if I pass, let's say root. Okay, so let's say I have left length, which is equals to what? F root left, and let's say I have right length, F root right. So what do we do? Return left length plus right length plus 1. And if root equal to null, return 0. This is a normal function of what? Like finding the length. But only length parameter can be passed, like int, when I return. But one thing that we want, four extra parameters also. So I will pass these four parameter by reference. First thing is minimum length. That is out of these four parameter because I want to find the minimum length. I can make this minimum length here as well, but I am passing it by reference. Doesn't matter. Okay. Now, four parameters were sum, length, but length is passed. Okay. Next is bool flag. Why? To tell whether the below tree is BST. Okay. Next, maximum till below subtree, minimum till below subtree. Okay. So like this, maximum minimum of this tree like this. So when I call this left length, so I will pass these parameters, minimum length, sum. So what I will do, I will make these parameters, make these four parameters first for left subtree and right subtree. Just understand, left sum is equal to 0 and right sum is equal to 0. Some parameters created. Similarly, left flag is equals to true. Let's say my below subtree is BST. Right flag is equals to true. Now, next thing, left maximum is equal to minus 29 as we're doing. Right maximum is equals to minus 29. Similarly, right maximum, like left minimum is equal to 189 and right minimum is equal to 189. So these four parameters I have created. Okay. So just see. Okay. Now I will pass these four parameters. Left sum, for left subtree, I will pass left sum, left flag, left maximum, left minimum. Similarly, I will pass right sum, right flag, right maximum, right minimum. So what I will say that that firstly, first thing that we want, that we are getting the left sum from the below subtree, like that. Left subtree sum, left tree is BST, left maximum, total left subtree maximum, total left subtree minimum, like this we are getting. Now, now, now we have to check for current tree using these left and right. So what we do, like we have sum. So what we will do? The current sum should be root data plus what? Uh, left sum plus right sum. Okay. And then next thing we will take like current length. What will be current length? It is equal to left length plus right length plus 1. So we can just directly return current length here. Okay. Now, now what we want, the maximum till current tree. Maximum is equals to maxi, comma maximum of, means maximum of root data. Current maximum, as I already told, left maximum, right maximum. Similarly, minimum is equal to minimum of root data, comma minimum of left minimum. comma, right minimum. Now, flag is equals to false initially. So what I will check, if current data is greater than left maximum and current data is less than right minimum, and so we are checking like this, it should be greater than left maximum and right minimum. And if less subtree is like BST, okay. If right subtree is also BST, yes. So if these two things are followed, I will say flag is equal to true. That means current tree is also BST. Current tree is also BST. Okay. So what are these parameters? These parameters are like below subtrees, sum is BST, maximum, minimum, left and right subtree, like these all things are like these all things are sum, BST, maximum, minimum, left and right subtree. Now, now the time to check whether this length is minimum. So I will say if current length is less than minimum length, if it is, that means also one more thing. If the sum is equal to target, that is the sum that I've calculated till the current tree is equal to target. Also, is it BST? Yes. If these all things are followed, I will update minimum length is equal to current length. And just like I get this minimum length, now I have to call this function. So obviously, sum is equal to 0. Minimum length is equal to 189 minus 29. As such, it doesn't matter whatever we write here because we are going to update the values always here. Okay. So now bool flag is equals to true. Like for root tree, I'm checking root, comma target, comma sum. Like I am passing root, comma next thing is minimum length. That we're going to update. So at the end we are going to return the minimum length only. And sum, okay. Then flag, okay. Because we are passing by reference, so we have to create the elements. We have to declare the variables here. Otherwise, it will give error. Okay. Now maximum, minimum, and call like this. So if the minimum length is equal to 1, that means we have not found, we'll return -1, else return minimum length. So let's try to compile in the code and check whether it's working fine. So there are some errors. No matching function for call to this. Yes, I forget passing this min length here. Let's try to compile in the code again and check whether it's working fine. Because it's root, so obviously I have to check root data. It should be root data. And next thing is current length. Current length is capital L. So these are variables error, obviously. So while explaining these errors, obviously error happens, right? Let's see if this sum is equal to target. I think I forget passing target here. I have to pass the target. How can I check that whether the sum is equal to target? Pass anywhere, like target here. Target. Let's try to compare the code again. Yes. So let's try to submit the code. So yes, it's totally working fine. So one attempt was made wrong because I forget to check whether the below tree is VSC or not. So this was all about code. So if you like the explanation, please like, share, and subscribe to my channel. Thank you and have a nice